Oh, hi there. I didn't see you there for a moment. I'm just over here looking at my DVD shelf. I have 3 DVD shelves full of movies because I'm an old person and I love physical media. I also have another one in our living room. But I've decided that for today, what we're going to do is I'm just going to talk to introduce our lesson today over area about some random movie from my shelf, and I have to make it about area. So I just picked one out of nowhere. It is Weird Al Yankovic's UHF. So I have to figure out, how is UHF, a film about Weird Al Yankovic, running a TV station about area formulas? And that answer is actually relatively simple. You see, he's running a UHF station, and UHF stations have a more limited range that they cover than the VHF stations that would be channels like 1 through 13 on really, really old TVs back before any of you were born. So instead, a UHF station would actually have a much shorter area that it would be able to do. And did you just hear the word I used? That's right. I just naturally got to it, completely without any planning whatsoever, for sure. Area. And UHF, currently available to watch on the retailer of your choice. This is geometry. So today we're going to be talking about just the area of triangles and quadrilaterals. So today is mostly just formulas, and we're going to start with the formula for the area of a triangle. So basically, when we have a triangle, like this one right here, we have the height. And we also have a base. Now, you might be thinking, oh, base times height. But remember, this ends up being half of like what a rectangle would be if we had the exact same size. You've already heard this, but still, just think if we moved this side over to right over here, we would end up having a rectangle, and that would be height times, well, half of this base. So our formula ends up being base 1/2 of base times height, or base times height divided by 2. So now let's talk about the area of a parallelogram. Well, with a parallelogram, it's a lot like a rectangle. And when I say a lot like a rectangle, I mean we have a height and we have a base. It's just the part right here has been moved from over here, meaning we have the same formula as we would for the rectangle, which you already know, as base times height. So now, though, let's talk about what happens if we have a trapezoid. So if we have a trapezoid, which once again looks like this, we still have our same height that we've been having before, but now we don't just have one base up here, we have a second base down here. And the thing is, it's not going to be the full size of a parallelogram or a rectangle with that size base. It's not going to be the size of a rectangle or parallelogram with this top size base either. It's going to end up being the average of the two. So we have to add them together, multiply them by the height, but then divide by 2. So the area of a trapezoid is base 1 plus base 2 times height divided by 2. Honestly, I tend to think of it as b1 plus b2 divided by 2 times height, because writing it this way makes me remember, oh yeah, that is an average. It's a mean. And so I like to think of it this way, but this is our formula right over here. Finally, we have the area of a kite or a rhombus. Now you might be like, a rhombus, that's a parallelogram. That means base times height. And that is one of the options that we have. But what we end up also having is this option. So with any sort of a rhombus, we have D1 diagonal and a second diagonal. Diagonal 1 plus diagonal 2. Now, I want us to think, before we actually write out the formula, think of it as, oh, there's a triangle up here and a triangle down there. If we had that, the triangle up on top would have a formula of 1/2. Ooh, I do not want to use that color. I'm going to use red. So what we do is we would have 1/2 of the base, which is diagonal 1, times the height, which is 1/2 diagonal 2. Now, because the height would only be the half up here on top. But here's the thing. The formula of the bottom half would also be 1/2 diagonal 1 times half of the second diagonal. Now if we added those together, we end up getting a whole diagonal 1 times half of the diagonal. But we would never write it that way with the half in the middle. We would get 1/2 of d1 times d2, which leads us to me officially writing it right over here. The area of a kite or rhombus is d1 times d2 divided by 2. So now let's actually try to find some areas. Well, find one area. So this problem right here, we have to first off figure out the length of both d1 and d2. So to figure out d1, which I'm going to say, to figure out d2, which is the vertical one, I'm going to call that d2. We need to figure out this whole thing. Now this is a kite. That means that this diagonal is bisecting this one, meaning we can actually already state that this diagonal, that this part is 7 square roots of 3 as well. So then, okay, 7 square roots of 3, 7 square roots of 3, that's going to be 14 square roots of 3. Now let's talk about what our other diagonal is going to be. So to do that, I kind of want to redraw this to give you an idea. So I'm going to show you that this is 14, this is x, and this is 7 square roots of 3. Now, we could do Pythagorean theorem. 14 squared equals 7 square roots of 3 squared plus x squared, but I'm actually not going to do that. And the reason why is I actually kind of recognize what this is. Now remember, this is a kite, which means that this is actually a right triangle here. And wait a second, 14 and 7 is half of 14. That means this is a 30, 60, 90 triangle, which means this bottom side is 7. So this part right here, just going to write it in, is 7. Now that leads us to our big triangle. So in this case, we already know that this is 14 square roots of 3 and this is 7 square roots of 3. So I'm going to draw that out like this. So 7 root 3, 14 root 3. Wait a second. This number is half of the hypotenuse, which means this is going to be that number, 7 square roots of 3 times the square root of 3, or 7 times 3, or, wait, that's right, 21. So now we actually have our formula here. We have 1/2 of, let's see, 1/2 of 7 plus 21 times 7 square roots of 3 plus 7 square roots of 3. So this becomes 1/2 of 28 times 14 square roots of 3. So at that point, the square root of 3 is going to stay the same. But now I just need to do, let's see, so what is half of 28 times 14 square roots of 3? I get into my calculator, and I just say 14 times 28 divided by 2, and that gets us 196 square roots of 3. If we were told to round to the nearest tenth, which would be horrific and bad, and I would hate it so much. Seriously, decimals are the worst. 196 square roots of 3, and the calculator becomes 339.48. So I am going to say, or, wait, I forgot to write, inches squared, or 339.5 inches squared, approximately. All right, so now that we've done that, we're going to try a couple of other things. So in this case, we have to find the value of h. So what I know is I'm going to try to do this, and this looks like it is a parallelogram. In fact, I'm going to just say it is a parallelogram, because if it's not, this question doesn't work. So here's the thing. If I wanted to find h, well, I know that the area of this is going to be base times height, which means I could say that the area is, our base is, well, 3 times our height of h. But there is actually another area that we could do. If we were to bring this figure to its side to where this was the base, we could also say that the area is base times height, which means 3h equals 12. At that point, we divide by 3, and what we discover is that h equals 4. All right, let's try another one. So in this case, this is going to be the exact same process as before. So once again, area is base times height. So in this case, area is equal to 25h. But we also know that area is equal to, in this case, we could create this figure. So base, so area is equal to the base of 15 times the height of 20. That means that 25h is equal to 15 times 20. Well, 15 times 2 is 30, times 10 is 300. This is the answer almost. So we have to then divide by 25. 25 goes into 100 4 times. 4 times 3 means that our height is 12 meters. And there we go. The only thing left to do at this point is something only you can choose to do. Do you have it in your heart? Can you like and subscribe? By merely pressing that button, you can help a simple teacher in need. Please like and subscribe. Thank you so much, and have a wonderful day.